Hi, welcome back to The Void. I'm going to show you a quick demonstration today of Multisim and a real-life circuit as well. I'm going to show you how they are intrinsically linked and how you can use simulations to benefit your own circuits. So let's begin in real life this time. Here we are in real life. These are my real hands here. We're starting off today with a very simple circuit. I have here a mini Arduino, not one that you'll be using, just one for this demonstration. And I have a single resistor here, which we don't know the value of yet. We're going to find that out with our multimeter here. And I've got two wires, one connecting into the ground just now. Don't worry about the columns that it's in. I'm going to show you what we're going to do later. So it's not actually connected to power just now. We're going to do an ammeter test at one point to find out the current. But just now our first task is just to find the resistance in real life with the multimeter. So let's connect our COM ports here and let's see what it sits on. Jumping around a bit, see if I can get a better connection. So I'm going on the insides here and I'm pushing out to hold it in place. It looks to be about 620. So we're going to say that's 620 ohms there. That seems pretty precise. It's not moving at all. You'll see if I take it off, it does jump. Whereas if I put it back in, yeah, so the multimeter is giving us 620 ohms. So we're going to stick with that. We'll say it's 620. Next, I'm going to move this over to here, and we're putting 5 volts into it. 5 volts comes from the Arduino here, and I'm going to measure the current going through it by tapping the exposed wires here. And usually we wouldn't encourage you to tap exposed wires, but in this case we're dealing with very low currents, and it's also necessary for this experiment. So, okay, now we're going to record the current. So I have got my COM port switched in and I've got my milliamps port switched in, not 10 amps because we're not dealing with high currents here. It's very small currents, very small. So we're going to get our two leads here, and what I'm going to do is I am going to touch the exposed ends of the wires, which, like I said, we're not supposed to do, but very small currents, so this is how we use the multimeter here. We're not dealing with dangerous voltages or dangerous currents. So you want to get a nice secure connection. Might take some positioning. Good connection there. Touch it on, and what you're going to, looks like they're around the wrong way. If you see a negative sign, it means your current is the wrong way, so you just need to switch your connections around. Let's see what we can get here. We're expecting probably a bit higher than that. It takes quite a bit of patience with the current because it does switch around quite a lot. It fluctuates, and you need to wait until you've got a stable value. So that looks to be about 7.68. Yeah, so it's holding just below 7.7 milliamps. Yeah, it's fluctuating quite a lot. It's not a great connection. Yeah, so about 7.7 milliamps. Okay, so our current is 7.7 milliamps then. So I'm going to move the red wire over as well so we can actually measure voltage. So now the red wire is in the same column as the resistor. That means we have a complete circuit, and we can see we have a voltage of around 4.85. So 4.85 volts in real life. So now we're going to switch over to Multisim. I'm going to show you how we can use Multisim to simulate this real life circuit online as well, and we'll see if the values match the values that we've got. So let's switch over. Here we are. So we're going to add in a power supply first. So in Multisim, it's in here, and we go to DC voltage. Now we've got our part. I'm going to bring it in, place it here in the center, and then I'm going to get our resistor. Here's just a standard resistor in Multisim. Don't worry about the values, we'll change that in a wee second. I'm going to add in the ground as well. There's our ground. I'm going to connect up the wires, so this bit is very particular. There we go. So you have to hover over and get exactly the right spot and then connect them. So that goes to ground. Ground is just going to take it down to 0 volts, and then we're bringing this one round to ground as well. And to get a voltmeter and an ammeter in Multisim, you go up to the top here and then select voltage and current. So because we only get one reading out, I'm going to select one and put one here at the beginning, and then I'm going to put one after the resistor as well over here. So let's change the resistor to what we had, which was about 620 ohms. The voltage, if you remember, was about 4.85. So 4.85 volts. And we're going to see when we run the circuit if it matches our current. Now the current was about 7.7, so we want to see if we get a value down here close to 7.7 milliamps. So let's see when we run it. And we get 7.8 milliamps. That's pretty close. So that seems like a pretty good simulation to me. That seems pretty accurate. We're only off by 0.1 milliamps in the simulation. So the simulation says under perfect conditions with 4.85 volts, 620 ohms precisely, no other resistances in the wires, in the board, anything else, then we would get a current of 7.8 milliamps. And we can do it backwards as well. If we have a voltage of 4.85 and we have a current of 7.8 milliamps, then we can calculate using Ohm's law that we would get 620 ohms. And if you do it yourself, then Ohm's law will match the simulation. And you can see that Ohm's law for the real life version of our circuit is an approximation, because there are other errors and other uncertainties involved, such as the internal resistance of our board, and there's also the internal resistance of any wires, although that might be very small. There's also the breadboard as well, and the resistor as well might be damaged, or it might not be precisely what it says. The multimeter measurements could be off as well, so there's loads of places in real life where it could go wrong, but in the simulation, you'll get exactly what it should be according to the physical laws that we know so far. Thanks very much for watching. That's all for now. I'm going back to the void. I'll remain here for the rest of time, but you will continue with your physics labs, and I hope this video was helpful to you. Thanks, and bye.